Hello, my name is Andrea Bravo. The subject that corresponds to my expose is some absorbing properties of perforated composite panels of recycled rubber, fiber, sawdust, and high-density polyethylene. In the abstract, recycling natural or synthetic polymers, typical was rubber, may find their novel usage in the production of acoustic materials for their good impedance properties. To that end, rubber granulates from used tires, high-density fiber, fluorine, sawdust, and fresh pellets were fully blended at a program-made ratio of 18, 40, and 42% with 5% as coupling agent based on overall weight. The mixture was more pressed into composite panels at 185 for 20 minutes. The material's high-density fiber sawdust was acquired from a small mill used to make floorings. In South China, such waste were overwhelmingly made of planted poplar wood with melamine, modified urea formaldehyde resin as the adhesive. The HDA sawdust was oven dried in lab resulting in random sizes smaller than 2 fresh high-density polyethylene pallets and recycled rubber granules were purchased from market. The methods: acoustic sample fabrication. Rubber granules and pellets were fully blended at report mass ratio of 40-18 and 42% with 5% based on overall weight in literature, following the program patent pricing parameters. The mixed raw materials were directly mold present in 5 thick acoustic test samples. The second is acoustic measurement. Following the ISO standard, the transfer function method was used to test the sound absorption coefficients of the perforated samples. Impedance testing and analyzing systems was used. The system contains a sound source, a sound transmission tube, and a sample fixing tube. In the data analysis, resonant frequency prediction. Resonant frequency prediction to mathematical depict general models to calculate the resonant frequency of a Helmholtz resonator is a given as where AF, the resonant frequency of the resonator, its sound propagation speed in air. EAS is cross-sectional area of the aperture. B is the static volume of the cavity and is the equivalent length of the aperture within the corrections. Is relative to frequency, as shown in the figure 3, sound pressures and microphone were measured and their transfer function were calculated as a function of frequency were then calculated and output through a computer software from a CAC frequency curve for characteristic acoustic index can be extracted. Results and discussions. According to the question, the natural frequency of a resonating system contain a perforated panel is decided by four structural parameters: perforation radius, cavity depth, panel thickness, and aperture size. Present the fitness or calculate values from equation and test data. The conclusions: this research fabricated a new acoustic material using recycled rubber in fibrous sawdust with fresh as the binder. A perforated panel combined with the impedance fixing tube actually forms a Helmholtz resonator. Its sound absorbing performance is affected by three structural parameters. Thank you.